So I'm going to go over the 2.1 through 2.3 test number 2 review. So these are some type of questions that you may see on the test on Thursday. The first one says list the domain and range, and then name if it's a function, if so, what type of function. So our domain is our x values. So here our domain is what's on top. So we have 11, 22, 33, 44, and 55. Remember, if a number repeats, we don't write it twice in our domain or range. So that means our range is what's on the bottom. So we have 8, 16, 24, 32, and 40. Now 11 goes with 8, so I'm going to put our arrows here. 22 goes with 16, 33 goes with 24, 44 goes with 32, and 55 goes with 40. Because all of these match up perfectly, this means that it is a function and it is both one-to-one and onto. So this would be both. So remember, when it matches up perfectly, everything gets an arrow, it is both one-to-one and onto. So for part B, again, we're going to list our domain and range. Our domain is the x values, so our first number. So we have 1. When we have 1 again, we don't list it again. So we just have 1, and then 2, and 3. Our range is our y values, so we have 2, 3, 5, and 4. Now we match everything up, so 1 goes with 2, 1 also goes with 3, 2 goes with 5, and 3 goes with 4. We cannot have two arrows coming out of the same number. So this means that this is not a function. So we can't have two y values for one x value. That makes this not a function. Remember, when determining whether it is one-to-one or onto or both, check out that box in 2.1 notes, because that has good examples of each one of those. So let's look at number 2. State whether the graph is a function or not. So this is when we do our vertical line test. So we can put a vertical line anywhere through our graph, and if it only touches at one point, it passes the test. So this one passes the test, meaning that it is a function. For B, if we put a vertical line, it touches at 2 points here, so it fails the test, so this would not be a function. And then C, we can put a vertical line anywhere through our graph here, and it will only touch at 1 point, so this is a function. So whenever it gives you a graph and you need to determine if it's a function or not, that's when you do your vertical line test. Number 3, is the function linear? So here we have certain rules of what makes a function linear or nonlinear. If we see one of our variables with an exponent other than 1, it is not linear. Here, our x has an exponent of 1. Nothing else is happening that's super special, so this is linear. For C, all of our variables have an exponent of 1, so this is linear. And D, this square root is x raised to the 1/2 power, so this is not linear. Also remember, another rule is that you can't have a variable in the denominator, so this would be not linear. And we also can't have an x and y multiplied by each other. So if we have x times y is equal to some number, this would be not linear. Can't have our x's and y's multiplied by each other. So those are just two more examples of nonlinear functions. For number 4, we need to write our equation in standard form and list a, b, and c. So standard form would be a times x plus times y is equal to our constant c. So we need to get it into this order to be in standard form, and then we can just list our a, b, and c. So for a, we need to get 6 over 5y to the other side. So since it's positive, it's being added on the right side. To move it to the other side, we are just going to subtract. So if we subtract it on one side, we need to subtract it on the other. So now we have 7 over 2 minus 6 over 5, or 7 over 2x, minus 6 over 5y plus 5 is equal to 0. We need to get this 5 to the other side, so since it's being added on the left side, we do the inverse operation, so we subtract it on both sides. So then we have 7 over 2x minus 6 over 5y is equal to negative 5. So now we list our a, b, and c. So our a is 7 over 2. Our b is negative 6 over 5. Can't forget that negative sign there. And then our c is negative 5. All right, let's take a look at b. So we need to get this into standard form. We don't have a y here, so we don't really need to worry about that, but we need our constant to go to the other side of the equal sign. So we're going to subtract 6 on both sides, so we have 5x is equal to negative 6, and that is standard form. Now we need to list our a, b, and c. So our a is what's in front of the x, which is 5. Our b is what's in front of the y. If there is no y, then our b is 0. And our c is negative 6. If we had a y with no number in front, so if we had x plus y is equal to 5, our x, or our a, so the number in front of the x, would be 1. So if there was no number in front, our a is 1, but if there's no y at all, so if we had no y at all, that would mean b is 0. So just make sure you guys know the difference there. All right, let's take a look at c. Here are equations in standard form, but we just have this equal to 5 on the left side instead of the right. So this is the same thing as saying 2x plus 3y is equal to 5. Because we can say a is equal to b or b is equal to a. That's the same thing. It doesn't matter which side our equal sign is on. So I'm just going to move it to the right side. So I'm not switching things in our equation around. I'm just moving the equals to 5 to the right side of our equation. And now it's in standard form. So our a is 2, our b is 3, and our c is 5. All right, let's look at number 5. We need to find the x and y intercepts and graph. So our x-intercept is when y is equal to 0. So we change our y to be 0, so we have 2x plus 12 is equal to 6 times 0. 6 times 0 is just 0, so we have 2x plus 12 is equal to 0. We need to solve for x, so we have to get our x all by itself. We're going to subtract 12 on both sides, so we have 2x is equal to negative 12. And then we divide by 2, so x is equal to negative 6. So our x-intercept is negative 6. Now we need our y-intercept. So y-intercept is when x is equal to 0. So we have 2 times 0 plus 12 is equal to 6y. 2 times 0 is just 0, so 12 is equal to 6y. We divide both sides by 6, So we get 2 is equal to y. So our y-intercept is 2. Now we can go to graph that. Our x-intercept crosses the x-axis, so it goes on our horizontal line. So we go to the left 6. And then our y-axis, our y-intercept crosses the y-axis, so we go up 2. And then we just connect our 2 dots with a line. All right, number 6. Given the function f of x is equal to 2x squared plus 8x plus 16, we need to solve for f of negative 2. So we take our number in the parentheses here and plug it into x. So we have 2 times negative 2 squared plus 8 times negative 2 plus 16. So negative 2 squared is 4. 8 times negative 2 becomes negative 16, and then plus 16. So negative 16 plus 16 cancel out. We're just left with 2 times 4, which is 8. So f of negative 2 is equal to 8. Now for b, we're plugging in 3k into all of our x's. So we have 2 times 3k squared plus 8 times 3k plus 16. So first thing we need to do is our 3k squared. So we have to square our 3 and square the k. So this becomes 2 times 9k squared plus 8 times 3k, so we can multiply our numbers together. So this is 24k plus 16. We can multiply our numbers together here. So this is 18k squared plus 24k plus 16. We don't have any like terms here, so this is our answer. This is f of 3k. So f of 3k is equal to 18k squared plus 24k plus 16. All right, let's look at 7. We need to find the rate of change and make sure we include the unit. So our rate of change is the same as the slope formula. So we have our y2 minus y1 over x2 minus x1. Our y2 would be our 50 down here. Our y1 is our starting y. Our x2 is our starting x, and our x1 is our starting x, and our x2 is our ending x. So we have our x1 and y1 together, our x2 and y2 together. Now we plug everything in. So we have 50 minus 10 over 15 minus 3. 50 minus 10 is 40. 15 minus 3 is 12. We can divide the top and the bottom here by 4 to simplify. So this is 10 over 3. And then we can just leave it as a fraction like this because we can't simplify it anymore. Okay, so that is the second page. Take a look at number 8. Again, we have to find the slope. We use that same formula, y2 minus y1 over x2 minus x1. So we have our x1, y1, x2, y2. Start with our y2. Which is 2 minus our y1 over our x2, which is negative 5, over our x1 minus 3. So this is 0 over negative 8. If we get a 0 on top, our slope is 0. So 0 on top automatically makes everything 0. For b, we have our x1, y1, x2, y2. plug everything in. We have negative 2 minus 4 over 0 minus 3. Negative 2 minus 4 is negative 6. 0 minus 3 is negative 3. Negative divided by a negative makes this a positive. 6 divided by 3 is 2. So our slope here is positive 2. And then last one, number 9, find the slope. We can either take these 2 points and plug them into our formula, or we can just count rise over run. So if we did rise over run, we are going up 1, 2, 3, 4. And then we go to the left 1, 2, 3, 4, 5. So our slope would be 4 over negative 5. So we can just plug that negative out front. So negative 4 over 5. We can also plug it into our formula. So we have y2 minus y1 over x2 minus x1. Our points. This point would be, we go to the right 1, 2, 3, 4, 5. So 5, and we go down 1, so 5, negative 1. Our point up here, we go up 3 and stay on 0. So this would be 0, 3. And now we plug everything in. So we have x1, y1, x2, y2. y2 is negative 1 minus 3 over x2 is 5 minus 0. Negative 1 minus 3 is negative 4. 5 minus 0 is 5. So this would be negative 4 over 5. Okay, and that is everything for the review.